Yeah. So already you have these basic skills, right? Basics of data warehouse, database, basics of statistics, basics of mathematics. Okay. Next, programming tools. At least you should master any one of the language, either Python or R language. Next, data wrangling. That is data cleaning. So they are data munging. So you can clean the data. If you have any erroneous data or unnecessary data or any missing values, you should clean the data and then you can start your model and you can build a model with the help of machine learning. Okay. And also you should know the basic knowledge of big data Hadoop technology. Okay. For the visualization purpose, either you can use um, Tableau or ClickView or any other business intelligence tools. Mainly 90% of the companies are using Tableau.
Okay.
Okay. These are the main skills are required for our data scientist. See here. So gain the database knowledge which is required to store and analyze the data. Whether it is Oracle or SQL Server or MySQL, Teradata. All of these are structured data. And also you should know about the basic knowledge of big data and Hadoop. Why? Because you can also apply your analysis or analytics against the semi-structured unstructured data also. Actually, big data has three characteristics. What are those? Volume, variety, and velocity. Okay. Volume means you can store huge amount of data. So how can you justify big data is how much big is big data? You can store up to 1 exabyte of data. 1 exabyte means 1024 zettabytes. 1 zettabyte is equal to 1024 exabytes. 1 exabyte is equal to 1024 petabytes. 1 petabyte is equal to 1024 terabytes. Right? Already you know what is gigabytes, what is megabyte, right?
Yeah,
So
yeah,
almost it is greater than of 1024 into 1024 into 1024 1024 times greater than of our normal database. So you can store up to 10 to the power of 24 bytes of data in your big data Hadoop technology. And also next character variety. You can store any type of data in your big data Hadoop technology, either structured data or semi-structured data or unstructured data. But in our normal databases, store only structured data. Okay. So generally in our traditional business intelligence systems apply their analytics only structured data. Either you can use SAP, BODS, BO, Business Object or BobJ or MicroStrategy or ClickView, MSBI, OBEW. So many BI tools are there. All are apply their analytics against the structured data only. But when you want to apply your analysis either on the semi-structured data or unstructured data, you can go for data, big data analytics. There is data science. So analytics is one of the part in our data scientist. So the both are not equal. Just it is one of the part only. You can also do some of the analytics in our traditional tools also. But you can do in that analysis, diagnostic analysis, descriptive analysis, maximum predictive analytics. But here you can do descriptive, diagnostic, predictive, and prescriptive analytics also. Prescriptive means which is based on all these analyses. Finally, what are the prescription? What are the prescriptive analysis have you given to the stakeholders? The companies or organizations or entrepreneurs take their decisions based upon our prescriptive analysis. Okay. Prescriptive means suppose if any guy got a fever, so they went to doctor, so the doctor give the complete prescription, right? So take tablets twice a day and take a tonic thrice a day and take an injection up to 3 days. When you follow this, the fever is cured. If you are not follow, fever is not cured, right? Same way,
of course.
based upon our analysis, companies or organizations, stakeholders or any entrepreneurs take the decisions. Either they want to release the products or they want to increase the production or decrease the production or they avoid unnecessary losses based upon our analysis. Okay. So this is the prescription. So mainly in the prescription analysis, you can use the machine learning. In that part, you are using the machine learning. So remaining thing, diagnostic or descriptive or predictive, you can do normal traditional business intelligence tools also. Here you can apply your analysis either semi-structured or unstructured data also. So that is the importance of our data scientist. And also you can use here statistics, probability, basic mathematics. That's why data scientist consists of some basic knowledge of big data, Hadoop, mathematics, probability, statistics, okay, and remaining things. You should learn at least one of the programming language, either Python, R, or SAS. So you can cover here both Python and R language. Okay, so as a data scientist, you should know all these things. But you can do as a teamwork, but you cannot do everything. So you cannot do each and every aspect of this data scientist. So we have the statisticians are available, mathematicians are available in our team, and analytics are available, big data engineers are available in our team. Okay, so we can communicate all of those ways, and we will develop one of the product. Simple definition. So we can convert the raw data into the product. That is called data science. So data science, you can convert the raw data into the products. That is called data science. Okay, so first we can discuss all these basic things. Next we will go to the further step. Here next, statistics. So learn statistics, probability, and mathematical analysis. So statistics, the science concerned with the developing and studying methods for collecting, analyzing, and interpreting and presenting the empirical data. Okay, so which is used mainly in the machine learning. Okay, the stats and probability and mathematics. So and also which is intermediate level, that is 10th class or intermediate level concepts are enough. Okay.
Okay.
Yeah. Next, programming. So you can master one of the programming language, either R language or Python language or SAS. Okay. If you know the Python, almost 70% of the chances to get a job. If you know the Python and R, 100% chances to get a job. So R, so why we go for Python? Python is an open source and general purpose programming. If you compare to any of the other languages, Python is very easy to learn compared to any of the other language, either R, SAS, C, C++, Java. You can compare to any of the language. Python is very easiest language. Okay, there are so many libraries are provided. So when you want to do the data analytics, you should import the NumPy, SciPy, Matplotlib for the purpose of to build the visualizations. Okay, so when you want to develop different type of graphs or charts, so you can import the Matplotlib. And scikit-learn for the when you want to build a models or build a product, you can import the scikit-learn for the purpose of machine learning implementation. Okay, NumPy, that is numerical Python. Almost you can do all mathematical analysis here, and some basics of stats. SciPy, this is scientific Python, which is based on the NumPy. Some of the basic packages are available, which is retrieved from the NumPy. SciPy, which is based on the NumPy, and Matplotlib, which is also based on NumPy, but you can create different type of visualizations. Okay, so this is Python. Next, R. R is also a free open source software for statistical computing and graphics. Support machine learning algorithms for data analytics like regression, association rules, and so on. But SAS is fully commercial, so the SAS won't provide even trial version also. Okay, but R is provide even fully commercial version also free. Okay, so mainly R is which is in the financial domains and insurance domains.
Okay.
So I can cover here both Python and R language. And data wrangling. So you can clean the data. So when you connect it to the raw data, so maybe that raw data contains any arranged data or unnecessary data, any missing data. So you first, when you want to apply or when you want to build a model, first you can want to apply the analysis. First you can clean the data. After that, then you can apply your analysis. Suppose you have any missing data is there, so you cannot apply your methods like statistical methods, any other things. You cannot get the proper result. That's why first you can clean the data. After that, you can apply your analysis. That is data wrangling or data mining or data cleaning. Okay, you can use this process. Either you can use R language or Python language or Flum or Scoop. Mainly you are using Python and R language here. And machine learning, which is very important for our data scientist. It's a subset of our data science. Okay, so master the concepts of machine learning, which provide the system the ability to automatically learn and improve from experience without being explicitly programmed. Okay, so if you want to understand this machine learning, first you should understand the uh, stats and probability and maths. Okay, that is also basic level, 10th or intermediate level. Okay, next, big data. So big data in term to describe large and complex data, so which
Yes.
cannot be deal with the traditional data processing software. So actually big data, which is a huge or large amount of data stored in our data centers. How much data you can store here? Up to 1 EB. Maybe in the future you can store 1 brontobyte of data. 1 brontobyte is equal to 10 to the power of 27 bytes. That is equal to 1024 EB.
Okay. Yeah.
So currently we are storing up to 1 EB of data. In future you can store up to 1 brontobyte of data. So actually in our normal traditional systems we have databases like Oracle, SQL Server, or Teradata, MySQL, so many relational databases. Here also we have NoSQL databases are there. NoSQL means not only SQL database. Not only means so which is not only store the structure, is also stored semi-structured and unstructured data. That's why you can call here NoSQL databases. What are those? Cassandra, MongoDB, Rake, Redis, Neo4j. These are NoSQL database. Hadoop's own database is HBase. Okay, these are all NoSQL databases. You can also connect the NoSQL databases and retrieve the data, and you can apply our analysis and build the product. Okay, so the evolution of data science is first already you know in 1970s we have only mainframes and databases, right? So then in 1980s we have data warehousing. In 1990s business intelligence. In 1999 we have data mining. So in the time of data mining we have already machine learning and data mining. You can also use 99 data machine learning also. So data mining contains complete mathematical analysis, statistical analysis. Then in 2003 or 2004, they are introduced the big data Hadoop technology, big data. Okay, so in earlier 2003, if you want to apply our analytics, only you can do traditional analytics. That is, you can apply our analysis only on the structured data. There is no tool to apply our analysis either on the semi-structured or unstructured data. So only you can apply our analysis on the structured data only. Okay. At that time, you are using MicroStrategy, OBIE, MSBIE, ClickView, SASBA, so many business intelligence tools are there. Okay. So next, in 2010 or 12 onwards, they reduce data science from 10 onwards. Okay. But you can apply here big data analytics. You can do analytics any type of data, either structure, semi-structure, unstructured data. Why? Because big data accepts any type of data. One of the characteristics, variety. So next, volume. Already I said to you, volume means you can store up to 1 EB of data. In future you can store 1 brontobyte of data. And variety means either you can store structured data, semi-structured data, or unstructured data. Okay. Next, velocity. How much fast you can process our data into the data centers. Generally, if you go for any relational databases, what is the speed to process our data? Suppose if you want to process 1 GB of data from source to destination, any of our relational database, how much processing speed? 5 MB per second. Processing speed is 5 MB per second. So suppose if you want to process 1 GB of data from source to destination, how much time it will take to process? 1 GB is equal to 1024 MB. So 1024 divided by 5 into 60. Almost it takes 3.5 minutes. Suppose if you go to any Windows system, almost it take to process our data 2 to 4 MB per second. Suppose if you take maximum capacity 4 MB per second. That is 1024 divided by 4 into 60. It takes 4.2 minutes. Suppose you go for Linux systems. So that is processing speed is 4 to 8 MB per second. Suppose you take 8 MB per second maximum size, 1024 divided by 8 into 60, 2.1 minute per second. Suppose you go for big data Hadoop technology in earlier versions from before 2012 or 2014, as they are using Hadoop 1.x version. At that time, you can process by default speed is 64 MB per second.
Oh, okay.
64 MB per second. Suppose you want to process 1 gigabyte of data, 1024 divided by 64 into 60. Almost it takes 2 seconds. Suppose currently in our from after 2012 onwards, they released to Hadoop 2.x version. Currently they are using 2.7 or 3.0. So now by default speed is 128 MB per second.
Oh,
And also if you want to increase the size, even though in the earlier versions, multiples of 64 up to 256. Currently we have 128 MB per second by default. But if you want to increase the size, suppose you have a huge amount of data, almost you want to process 1 petabyte of data from source to destination, you can increase the size. That is multiples of 128. Up to you can increase 512 MB per second. Okay. So these in this way you can increase the size up to 512 MB per second. So 1 petabyte of data to process the from source to destination almost it takes to process 12 hours. But 1 GB data, 40 microseconds. That much of speed. That is the one of the characteristic in our big data velocity. Mainly big data based on these three characteristics. Okay. So here so we have used Spark. Spark supports online data also. Actually, what is the difference between big data and relational databases? Relational database accepts online transactions. But whereas in big data, it cannot support online transactions, only it supports offline batch job processes. Okay. So here in our normal database support only structured data, big data support either structured, semi-structured, unstructured data. In our normal database processing speed is 5 MB per second, but our big data Hadoop technology nowadays 128 MB per second to process speed.
So Hadoop cannot support this live data from like this websites
So
and
when
social media.
yeah, in our 2.x version, so from 2012 onwards, the 2.x version, we are integrate Spark, one of the tool. You can integrate with Hadoop. At that time onwards, it also accepts online transactions. So we have store in our cache memory. Up to when you want to integrate Spark, you should maintain the 32 GB RAM in your system. So it also accepts online transactions. So you can process the data, you can apply our analytics. You have 4 types of libraries are there in Spark. One of the process streaming. So it also accepts online transactions also from 2.7 onwards. When you integrate Spark with your Hadoop, okay. Now it is it accepts online transactions also. So these are the main differences. So when you want to apply our analytics, if you want to apply our analytics against the semi-structured unstructured data, you should go for either Python or R language or Splunk. Okay. So you can integrate with Spark, Hadoop, or any data center or NoSQL databases. You can use the Tableau, one of the visualization tool. Okay. So these are required to do as a data scientist. Okay. Here, Cassandra is one of the NoSQL databases. Next, data visualization purpose. So data visualization involves integrating a different data sets and analyzing the models and visualizing them in the form of diagrams, charts, and graphs. Either you can use Google Data Studio, Power BI, Microsoft Power BI, or Tableau, ClickView. But so many companies are using Tableau, 80% of the companies. So some specific requirement is there. Some of the companies are using Power BI, Microsoft company. So Google Data Studio, ClickView. But easiest tool is Tableau. Here, next, so what is data science? Why we go for this? So data science is about finding and exploring the data in real world and then using the knowledge to solve the business problem. Suppose, for example, customer prediction. So system can be trained based on the customer behavior pattern to predict the likelihood of a customer buying a product. In which time the customer bought the product in the in normal days, in weekdays, the customer the in which time the customer bought the products after 10 o'clock, after 9 o'clock, after 9 p.m. or 8 10 p.m. In weekends, in which time the customer uh, bought the products, or if you go to the customer will go to any type of retail stores, so which product they are preferred in that weekend times. So in this way you can do the analysis based on that. They will increase that particular products and which is put into the nearby the cash counters. Why? Because they won't uh, they won't allow the this uh, what is that, ఏమంటారంటే ఇది వాళ్ళ టైం అసలు మనం వేస్ట్ చేయకుండా ఉండడం కోసం ఆ
ఓకే,
పర్టికులర్ ప్రొడక్ట్స్ అన్ని
కన్వీనియంట్
కూడా
కన్వీనియంట్
నియర్
కన్వీనియంట్ కోసం
క్యాష్ కౌంటర్ నియర్ బై పెడతారన్నమాట. అంటే మనం మొత్తం స్టోర్ అంతా ఫస్ట్ ఫ్లోర్, సెకండ్ ఫ్లోర్, థర్డ్ ఇలా అన్ని వెతుక్కోకుండా నియర్ బై పెడతారు. సో ఈ టైప్ ఆఫ్
కన్వీనియన్స్
అనాలిసిస్
కోసం.
చేస్తారు. They won't waste of our customers' time. Okay,
Yes, yes.
these type of things you can do with our data science products. Okay, there are so many products you can develop here with the help of data science. So data science is a multidisciplinary blend of data inference, algorithm development, and technology in order to solve analytically complex problems. So at the core is data, so which is proofs of raw information streaming in and stored in an enterprise and data warehouses. So much to learn by mining it. Advanced capabilities we can build with it. So data science is ultimately about using the data in creative ways to generate the business value. Okay, see here. Already I said to data evaluation of data science. So these are the different type of examples. So why are all the excitements? So exciting new effective applications of data analytics, for example, Google flu trends and detecting outbreaks 2 weeks ahead of CDC data or IDC data. And new models are estimating which cities are most at risk for spread of the Ebola virus. Currently, we are doing current situation is coronavirus, right? So which you can also apply different type of analysis how to avoid this coronavirus and how what are the cities are most at risk, how to avoid this. So you can apply different type of analysis and you can give the prescription. So when the cities which are follow those prescriptions, they avoid the these type of viruses. So you can apply based on the data. You can use some of the analysis. Okay, predicting the model is built on various data sources and types in analysis. Here, data science discover of data insights. So this aspect of data science is all about uncovering findings from the data. So diving in at a granular level to mine and understand the complex behaviors, trends, and inferences. It's about surfacing hidden insight that can help enable the companies to make smarter business decisions. So what are the examples? So Netflix data mines moving patterns to understand what drives users' interest and uses the what to make the decisions on which Netflix original series to produce. So if you want to see any a picture, so you can search the picture, automatically it display the out of 5 top rated movies, almost 4.7 4.5 top rated movies are suggested, right? You can see any of the either you can you want comedy pictures or action pictures or dramatic or horror pictures, whatever you want, it gives the high top rated movies. Suppose if you know the title, So they will the Netflix displays that movie, and also they suggest you the some of the movies, that related movies, either in the right hand side or bottom. So this is the recommendation engine, one of the data science product. Next, if you go to target, that is target identifies which are major customer segments within its base and the unique shopping behaviors within those segments, which helps to guide messagings to different make audiences. Suppose you go for Procter and Gamble, which utilizes the time series models to more clearly understand future demand, which help plan production levels uh, levels more optimally. How do data scientists mine out insights? How do data scientists mine out insights? It starts with the data exploration. First, you can identify the raw data, then you can apply the data exploration. You can apply different type of analysis, then you can process the data into your environments. After that, when you want to build a model, you can apply data mining and data wrangling. That is data cleaning. After that, you can build a model with the help of machining. You can choose any one of the algorithm from the machining. So the investigating leads and try to understand the pattern or characteristics within the data. So this requires a big dose of analytics creativity. Okay. So data scientists may apply quantitative technique in order to get a level deeper. For example, inferential models, segmentation analysis, time series forecasting, synthetic control experiments, and so on. Okay. Next, data science to develop the data product. Already said to you, a simple definition of data science is to convert the data into the data product. Raw data converted to data product, development of data products. So a data product is a technical asset that first utilizes the data as input, and then second to process the data to return algorithmically generated the results. The classic example of data product is recommendation engine, which ingests user data and makes personalized recommendations based on the data. So what are the examples? We have Amazon's recommendation engine suggests the items for you to buy, determined by their algorithms. Suppose if you want to buy any type of article in our Amazon, suppose the product is available, it displays the product, and also it suggests you some of the related products, either in the right hand side or bottom. Okay. So suppose if that product is not available, that related products are displayed. So how they know? Because of recommendation engine, one of the product in our data science. And Netflix recommends movies to you. Spotify recommends music to you. The Gmail spam filter is a data product. Suppose if you send any mail to your destination in your recipient, automatically is it important mail? It is going to store in your inbox. It is not important. Is any add any other mail automatically move to the spam. How they know? Because of our data science product. Yes, Gmail spam filter is a data product. An algorithm behind the scenes processes incoming mail and determines if a message is junk or not. And also, computer vision used for the self-driving cars is also data product. Currently, self-driving cars, that is robotic cars, or robotic drones, robotic containers already released. Okay, so machine learning algorithms are able to recognize traffic lights, other cars on the road, and pedestrians, and so on. Automatically recognize based upon the sensor data. This is also one of the product in our data science. So this is different from the data insights, okay, where the outcome that is to perhaps provide an advice to an executive to make smarter business decisions. In contrast, a data product is a technical functionality that encapsulates an algorithm and designed to integrate directly into core applications. Okay. So next, where does data come from? Where is the data come from? Either on the text files, that is flat files, text files or XML files or comma separated value files. That is all are flat files, or you can connect it to any type of relational database management systems. That is only contains structured data, or you can connect any NoSQL databases, or you can connect any big data Hadoop data centers. Okay, a small data sources or big data sources. Okay, so either Facebook, these are completely unstructured. Either Facebook data or YouTube, Twitter, Help, and so on. The user generated web or mobile, or health or scientific computing, Internet of Things or M2M. Okay. Next, online transactions. See here, we have so many relation databases are there. Those are Oracle, Sybase, MySQL. So these are NoSQL databases, only structured databases. Okay, and we have so many relation database management systems are there, right? DB to DBA, Red, that is Sybase, Oracle, SQL Server, MySQL, MS Access. So many databases are there. Okay, these are all relational databases, and also you have NoSQL databases are there, which are belongs to big data Hadoop technology. That is MongoDB, Cassandra, Redis, Neo4j, CoachDB, HBase, and so on. So you can connect any type of data, either in the structured databases or flat files or relational databases, NoSQL database or in data centers. You can connect any type of data. Already we have discussed what are the characteristics of big data. So today's business environment requires big data. Here, in our earlier days, already we have discussed this here. So in earlier days, we are following this structure only. In our earlier 2003. So you can connect any relational databases, whether it is uh, financial data or HR data, whatever it is. These are relational databases. Okay, it follows OLTP, online transaction processing, and also it follows the uh, ER modeling, entity relationship model. After that, you can process the data with the help of any ETL tools, either Informatica, DataStage, SAP, BODS, or Ab Initio. These type of tools, you can process the data. That is extracting, transfer, meanwhile clean and scrub the data, and load the data in our traditional enterprise data warehouses. Then you can apply your analysis against the data warehouse. So you can use any one of the BI, either MicroStrategy, MSBI, ClickView, OBIE, SAS BI, so many BI tools are there. But you can apply only your analytics against the structured data only. So when you want to do the big data analytics, so the big data is required. So when it is available from 2004 or 3 onwards, okay, big data contains any type of data, structure, semi-structure, unstructured data. Okay. So currently in our market, big data is available. That means traditional data is not required. Big data, Hadoop technology overrides the traditional databases. No, both are communicate each other.
Okay.
Parallelly, we are using both the things. So big data cannot overcome this. Okay, we can parallelly use both the things. So 100 years of companies, we have stored so many data in our databases, right? So you can use both the things in our environment. So you can use here Scoop technology. Scoop retrieves the our traditional data and process to either NoSQL databases or Hive. Hive is which is a distributed data warehouse. Already have the traditional data warehouse here, but in our big data also we have one of the tool is Hive. Hive is a distributed data warehouse. Already you have some of the ETL tools are available in our traditional tool in a traditional business environment. That is Informatica, Data Stage, Ab Initio, or SAP BODS. Here, Pig is like an ETL tool. So if you want to work for this, you should know about the SQL structure query language.
Mm.
Okay, so with the help of Scoop, what are the data you have in our traditional systems? You can retrieve it. You can store either in the NoSQL databases or Hive or big data center, that is HDFS, Hadoop distributed file system. Okay, so you can integrate so many tools here, either Spark, MapReduce, or Pig, Hive, Mahat. So many tools you can integrate your Hadoop technology. Okay, Spark accept online transactions also,
Mm.
like our traditional systems. Okay, now in our today's business environment, you can accept any online transactional data, either EMR, EHR data, or ICD or CDC data, any social media data. Social media means either it is structured, semester, unstructured data. It accepts. First, it can store into the NoSQL databases. NoSQL database maximum capacity 1 petabyte of data. So when that touches that data is touches the ceiling, which is moved into our HDFS. HDFS accepts up to 1 petabyte of data. So you can store the data here. Then when it is reaches the touches the ceiling, your data. Okay, so you can store the data. Hive is a distributed database. By default, it accepts the structured data. When you use the serialization, that is serialization, you can also move semi-structured data also. So when you have the data, that is the core data, that is either structured, semi-structured, or unstructured. Now you can start your big data analytics. So nowadays you are using data science. Here, big data analytics, that is data analytics, one of the part in our data science. With the help of this, either you can use Python or R language. Okay, you can do any type of analytics. Analytics is one of the part in our data science. Okay, you can generate different type of reporting, visualizations, ad hoc reports, and so on. This is our today's environment. Okay, see here. Next, why we go for data science? Yeah, fuel. This is the fuel of 21st century. Problem of demand and supply. So data is change the world. Data science future. A lucrative career is there. Okay, see here. Almost on an average salary, is $1,25,000 per annum. Okay, so what is the difference between analyst and data scientist? What is analyst and data scientist? We can do analyst is one of the part in our data science. Okay, analyst is somewhat of an ambiguous job that can be represent many different type of roles. That is data analyst, marketing analyst, operation analyst, financial analyst, and so on. So what does mean in a comparison of data scientist? So data scientist specialty role is the abilities in math, technology, business acumen. Okay, data scientists work at the raw database level to derive insights and build the data product. As an analyst, this can mean a lot of things. A common thread is that analysis look at data to try to gain insights. So analyst may interact with the data at both the database level or the summarized report level. So analyst and data scientist is not exactly synonymous, but also not mutually exclusive. Okay, so analyst means you can analyst doing some different type of administration work, that is domain specific responsibility. For example, marketing analyst, campaign management analyst, financial analyst, equity research, and data exploration analysis and insights. But as a data scientist, with these roles, there is analyst roles and as well as advanced algorithm machine learning and data product engineering. So this is data scientist. Okay. Next, these are the different type of analysis: descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So what is descriptive analytics? Based on the historical data, what happened in the history. So based on the historical data, you can generate different type of report. Descriptive. Suppose now you want to find what are my profits and revenue in different years, different area, different regions, and different products. So just you can drag year, region, and products, and drag your uh, measures, that is revenue and profit. Automatically some of the reports are generated. So now it display complete some of the profit and some of the revenues are generated in different year, different regions, and different products. So this is the descriptive analysis. So when you want to do the diagnostic analytics, why did it happen? Suppose now you want to analyze your data in micro way, that is micro analysis. That is, suppose now you are in the country level, or now you are in the region level, eastern region, western region, southern region, or western region. Okay, suppose you go to southern regions, now you want to apply your analysis southern countries or southern states like Telangana, Andhra, Karnataka, Tamil Nadu, like this. At that time you can drill down the data. That is, when you click on this, automatically when you click on the particular country, all countries are displayed. When you click on that particular southern states, so either eastern state or southern state or western state, just you can click on southern state, the southern states are displayed. Now you want to find out particular Hyderabad area only. Hyderabad also you have so many retail stores are there. Now you want to find out what is the revenue generated particular Hyderabad central, a particular DMart, a particular Walmart in particular area, either Ameerpet or either KPHB or Banjara Hills, whatever you want. You can do particular analysis. So what are the revenue generated in a particular products, particular electronic goods in Banjara Hills area only. Now you can do that. That is called diagnostic analytics. You can drill down the data from higher level to lower level. When you want to drill up from lower level to higher level, so that is branch level to country level or region level, or okay, these are called diagnostic analytics. Predictive analytics, what will happen in the future. That is, currently in last month I got 1 crore profit in my company. How much profit will I get in next month, or next quarter, or next year, or after 2 years? These type of analysis you can do with predictive analytics, which is also called time series analysis or forecasting. Predictive analysis, forecasting, or time series analysis. So based on this, we can do prescriptive analysis. How can we make it happen? So mainly prescriptive analysis, you can use machine learning. Okay. So based upon the data, what type of data we have, either is categorical data, there is qualitative data. There is uh, like true or false, yes or no, or colors blue, black, red, white, or binary value 0 or 1. So these type of categories, categorical data. Okay, you can apply classification algorithms or quantitative data, that is regression problems. Mainly you have the numerical data. When you have the quantitative data, you can apply regression algorithms. Quantitative and as well as continuous data, you can apply clustering algorithms. You can do here machine learning. So you have machine learning of two types, that is uh, supervised learning and unsupervised learning. So supervised learning having the classification and regression. Classification and regression both are quite similar, which are belongs to supervised learning. And unsupervised learning, clustering belongs to the unsupervised learning. It contains continuous and quantitative data. So based upon the data and domain, you can choose one of the algorithm from your machine learning and build a product. Based on the product, the clients take the decision. Not only clients or stakeholders or entrepreneurs, CEOs, CFOs, they're taking the decisions. So these type of analysis you can do here. Almost you can do all these analytics in our data scientist. So data analytics is one of the part in our data science. Okay, so you can do these type of products, any type of either e-commerce domain, manufacturing, banking, finance, transport, or healthcare. So you can do so many data science applications. Okay, if you want to do any type of project, you can based on the data science project lifecycle or workflow. So you don't go for each and every time to that from the raw from first step onwards. So maximum 80% of the work start from the exploratory data analysis. So rarely you can go for from raw data onwards. First step is raw data collected. Where is the raw data is available? First, raw data is available in the flat files. It is .csv files, .xml, .excel, comma separated value. These are flat files. Or you can connect it to any relational databases or any NoSQL databases or Spark or Splunk or any of the big data centers. First, you can identify the raw data. Then you can process the data into your environment. Second step is data is processed to your environment. Either you can use Python language or Python unit or R environments. After that, you can apply your exploratory data analysis. That means you can apply different type of analysis. That is, you can apply descriptive analysis or diagnostic analysis. Then, when you want to build a model, you can choose the algorithm. Before build a model, you can clean and scrub the data. Here, you can apply the data munging or data cleaning. Okay. So here you can apply based on the data. What type of data is available? You have two types of data is available, either quantitative data or qualitative data. And based upon the domain, you can choose one of the algorithm. Okay. Based on the domain and based on the data. Suppose you have a continuous data and 24/7 the data is coming. Suppose if I go for media domain, media means 24/7 the each and every 24 by each and every minute or each and every second the
like a TV channel.
media reporters send their data to their data centers, right?
Yes.
So after that each and every data which is stored in your data center, so when you want to um, display the bulletins, either 1 o'clock bulletin or 2 o'clock bulletin or 3 o'clock bulletin, you can segregate the data. Suppose you take ETV. ETV having so many channels, right? ETV Urdu, ETV Kannada, ETV Telugu, ETV Tamil, ETV Hindi, so many ETV Maratha, so many channels are there. But all over the world, 24/7, the reporters are send their data to the data centers. When the ETV Telugu news readers want to display the particular 1 o'clock bulletin or 2 o'clock bulletin or 3 o'clock bulletin, they segregate the data. They are retrieving all Telugu data, put into a cluster. What is cluster? They are taking similarities, similar characteristics or similar features they put into one particular area. That is called clustering. Okay. So Telugu data is put aside, Tamil data same way, Marathi, Hindi, all are based on the similarities or similar characters they put aside. Okay. Next, when the Telugu news readers are want to display the particular bulletins, they take that data. They give voiceovers or display audio for audio or video, so many things. So this is called media domain based on the continuous data. There is quantitative data. Suppose if you go for a retail domain, we are using here association rules algorithm. Here also you can take quantitative and as well as numerical data. Okay, you can apply here association rules, data mining methods, association rule. Next, if you go for social media data, suppose if you want to raise a question, who will be the next president of USA? So you can give some 15 days time or 20 days time. After that, you can collect the data and you can apply your analysis. Now you can decide who will be the next president of India, president of America. Automatically, after results, exactly 99% of the accurate results will be displayed. Even though in the earlier 4 years ago, so many guys, almost 90% of the people are expecting Hillary Clinton, but our Facebook and Twitter, these companies are apply their analysis and they declare the Trump is the next president. But these analyses are correct. Correct. Why? Because of our data science, they are taking the particular analysis from the customers, from particular voters, apply the exact analysis, and they uh, announce the next president is Trump. Exactly, Trump has been won that elections, right? Same way, We can do some of the either positive or negative sentiment analysis. So many things we can do for social media. So if you want to do that, you can use one of the media use case. You can use here K-means cluster. The market basket analysis. You can use here retail domain. Here association rule mining. Next, healthcare use cases. You can use here parallel processing. Social media use case. You can use here naive Bayes classifier. Already have the naive Bayes theorem is available in probability. Naive Bayes theorem. Same you can use that theorem. Naive Bayes classifier is used here in the social media use case. Okay. So based on the situation, based on the domain, based on the data, you can choose one of the algorithm from the machine learning. Okay. So based on that, you can build a model. Next, you can based on the product visualizations reports, the clients take the decisions. Then you can move that product into the reality. This is the complete data science project lifecycle or workflow. Okay, so these are the things you can use in different uh, particular step. Okay, raw data. Where is the raw data is available? In the source data. Where you can connect NoSQL databases or SQL databases or flat files or social media data, whatever it is. Okay, next data is processed. If you want to process the data, you can use Scoop or Hive to process our data into data centers or databases. Next, you can apply exploratory analysis. Either you can use Python language or R language, or you have so many third-party tools are there, Elastic Research, KNME, and so on. Okay. Next, if you want to build the models, you can use R language, SAS, SPSS, Pandas, Python, Julia, RapidMens, Clojure, Weka, Mahat. So many tools are, but most of the companies are using Python and R. Okay. So when you want to do the visualizations, so already you have integrated ggplot in our R, ggplot2 in our R, Go JP in our R. So already you know the SAP Go objects, Tableau. Tableau is also integrated to any big data centers or any type of NoSQL databases. Cognos, so many BA tools are there. Okay. Next, you can move that product into the reality. You can use the Python. So if you compare R and Python, here these are the differences and similarities.
Similar.
Yeah. If you go for model building purpose, both are similar. If you go for Python and R, model interpretability, R is better than Python. Production, Python is better than R. Community support, R has good community support over Python. Both are similar. Libraries and tools. We already integrated the ggplot to a ggplot. So learning curve, Python is very easy than R. Okay. So machine learning, already I said to you. So what is machine learning? What is the importance of machine learning? So the main goal of machine learning is to get software to make the decisions and learn from the data without being programmed explicitly to do so. We have two types of machine learning: supervised learning and unsupervised learning. Supervised learning is based on the label data. Okay, so based on the label data, you can give the outputs, single outputs. But when you go for unsupervised learning, you can use unlabeled data. That is, you can take similar features or similar characters which we put into a group of related data. Okay, not only single data or single value. Okay, you can give group of related data. That is unsupervised learning. Okay, here. So based upon the data, you can segregate these types. Actually, you have three types of problems: classification, regression, and clustering. Here, classification,
Regression clustering.
regression, and clustering. Classification and regression both are quite similar, which are belongs to supervised learning.
Supervised.
Clustering belongs to unsupervised learning. Okay. So how to do how when you go for classification and when you go for regression, based upon our data. So categorical data, quantitative data, or finite data, all are same. Categorical data means so you can categorize the data. Suppose if you go for binary, either 0 or 1. either true or false, or are you going to job today? Yes or no, or maybe. These are also categories. Or is it hot today? Whether it is yes or no. Or what are the colors we have? Green, black, red. These are categories. So when you want to apply our analysis against the categorical data or quantitative data, you can go for classification. The KNN algorithm, that is K nearest neighbor, or decision tree classification, logistic regression, naive-based classifier. Already I said to you, where you use naive-based classifier, social media data. Okay. Next, you have a continuous data and numerical data. You can go for regression, either linear regression, polynomial regression, decision tree regression, random forest regression. Okay. Next, you have a continuous data and clustering, that is numerical data. You can go for support vector dimensionality, principal component analysis, k-means clustering, hierarchical clustering. So when you go for k-means clustering, when you want to do your analysis in the media domain, you can go for k-means clustering. If you go for retail domain, association analysis, you can use here a priori algorithm, the FP growth. Here also you can use that data mining concept. So based on the data and domain, you can choose one of the algorithm in our machine learning. See here. So this is why we go for data science and why you choose the right career here based on the demand and supply. So currently almost, so the demand for data science is increasing so quickly. So based on the McKinsey predicted that by in the year 2020 or 50% gap is there. Okay, almost see here, 2.7 million career opportunities in data science in 2020. On an average salary as a fresher 6 lakhs per annum in India. Okay, what are the titles you have? Data scientist, data architect, data engineer, data analyst, or business data analyst, statistical data analyst. All are belongs to data science. Okay, these are different roles are there. R, machine learning, statistical analysis, and big data analytics. So these are these cases we have Facebook, Amazon, Uber, Bank of America, Airbnb, Spotify. Okay. Already I said to you, where you can use the machine in which domain. These are the use cases. So if you have any doubts, you can ask me. And we can start tomorrow from basic Python. Okay, from scratch onwards. This is the complete overview of data science. First, if you want to do any type of analysis, at least you should know any one of the language, either Python or R language. So you can start tomorrow Python language from basic concepts. Okay. So I can cover all concepts. So I can send you the complete curriculum here. I can send to you. So I can cover each and every concept. So after maybe it takes 70 hours. Within 2 months I can complete it. So maybe after a month you can easily get into the job. Okay, you can easily move into any domain. You can easily get the job. Okay, so you can follow daily. After 1 week, I can give the first tomorrow onwards. I can tell you the basics. So after 1 week, I can give some of the exercises and some assignments. You can practice it. If you cannot resolve, you cannot solve that. I can explain you the how to resolve that issues. Okay, I can give complete real-time questions.
Yes.
So what are the experience I have? What are the knowledge I have? I can completely transfer to you. Okay. So this is I have done. If you have any doubts, you can ask me.